So I wanted to work through number 3, which is the amusement park problem on your assignment with you. So, whoops, let me get my pen working. So let's read this problem first. It says, at an amusement park, the Ferris wheel has a diameter of 42 feet and is positioned 5 feet above the ground. So that's what this picture represents. My pen quit working. Oh, now it came back, and of course it messed me up. To ride costs 7 tickets, so that doesn't really matter for what we're trying to solve. So Charlie wants to time the ride to make sure he gets his money's worth. Once all the passengers loaded, the ride begins, and Charlie starts his stopwatch. He reaches the stopwatch, or the top, 9 seconds later. Why does my pen keep stopping on me? So let's label our graph here, and I'm going to switch to a different color than root. So if we go by tens, so 5 seconds, 10 seconds, 15, and so forth. 20, 25, 30, 35, 40, 45, and 50, and 55. So at 9 seconds, so just before 10 seconds, he's going to be at, what does it say? At 9 seconds, he's at the top, which, if you look at how high this is, the top is 47 feet. So, well, let's go, there's only 1, 2, 3, 4. Let's go by tens on these. So I'm going to make this one be 10, 20, 30, 40, 50, and 60. So 47 at 9 seconds. So here's my 9. He's going to be at 47. So that's about right in here. So 9, 47. That's just over 9 at 47. Well, he reaches the top 9 seconds later. He returns to the top when the stopwatch reads 33 seconds. So at 33 seconds, right about in here, he's back up at 9 again. So that's, not 9, 47. 33, 47. So that means that halfway in between, and halfway in between 9 and 33, he'll be at the lowest point, because you can't get from the top to the bottom. It's got to be equally symmetrical here. So 33 minus 9 is, what is 33 minus 9? 24 seconds? Yeah, so 24 seconds to get all the way from here, all the way over to here was 24 seconds. Hey, that tells us something important. That's our period. Period is 24 seconds. Because from the top of the ride back to the top of the ride is one full cycle. So the reason why would be that's the time it takes for the Ferris wheel to make one full revolution. I'll let you write that. I'm not going to write all that because this pen's not fun to try to write sentences with. So halfway in between 24 seconds, at 12 seconds, he'll be at the lowest point. So 9 plus, because I went halfway from 24. So 9 plus 12 is 21. So at 21, he'll be at the lowest point on this ride, which is at 5 feet. So at 21, we're at 5. So 21, 5. And so now we can see kind of what this it's supposed to be very curvy, like a sine or cosine graph, and then it just keeps repeating and keeps going, and I'm only going to just draw that one for now. We could actually go another 12 seconds from 33 and make 45. That one's nice and easy. Let's go ahead and do it. We're down here at 5. So it does that at 45. Whoops, I went a little slightly off. Sometimes when I look away from the screen for a second. And then it just keeps going. So you can see what the pattern does, and you can actually keep going before that, but we started at 9. So 24 seconds was our period. You saw the reason why. So we want to write a function in terms of cosine. Well, if you remember, a cosine graph starts at the highest point. Well, we're at the highest point. So I need to find the midway. Well, if you look at the y values, we went from 5. We were at 5, and we went all the way up to 47. So from 5 to 47, if we want to find the midpoint from 5 to 47, if you remember from geometry, 5 plus 47 divided by 2, well, that is 52 divided by 2, that's 26. 26 is the midpoint. So 26 is like my new x-axis. And if you want to find out what half of that is, if we do 47 minus 5, that is 42, and divide it by 2, that tells us it's 21. So 21 so it's 21 above and 21 below. So we now know we just found A value and we also found the D value. So okay, so I'm going to go back and let's see. A was our amplitude, and our amplitude went from the midpoint to the highest. Well, we went from 26 all the way up to 47. So we went up 21. So A was 21. And D, let's just go ahead and write D here. D was how much we shifted up our vertical shift, and we shifted up 26 units. Our period was 24. And so B is 2 pi divided by the period. So 2 pi divided by 24, which is pi over 12. And C, well, I need our phase shift. Our phase shift, we moved over. Normally cosine starts at the highest point at 0. Well, we shifted over 9 units. So this one had a phase shift of 9. So C is B times the phase shift. So that'd be pi over 12 times 9, which would be 9 pi over 12 reduces to divide by 3. Looks like 3 pi over 4. So now that I know all those values, I can actually write my equation, but I didn't leave myself much room to write it. So let me scroll this a little. And our equation, I'm going to move C and D over here for a second. So C is 3 pi over 4. And D is, I already wrote D, so B is the one I needed. B is pi over 12. So I'm going to put those there so that I can erase them over here. And then I'm going to, my eraser's not working very well. I'm going to fill those in. So when we erase these, when we get through erasing, now I can write my equation. H of t, that's our function. So H of t is equal to A, which was 21, cosine of B, which was pi over 12, and then our time, B over t, and we don't have a parentheses on our B. BT minus C, so forget that that parentheses is not supposed to be there because we changed this problem. So pi over 12 t minus our C, which is 3 pi over 4, and then plus 26. So that gets us through part C. To get part D, what was the height above the ground when the ride started? Well, we'd want to go back and find out what it was at time 0. So we want to back up 9 seconds. So where would this graph be if we go back 9 seconds? Well, one easy way to do that, plug in 0. So we want to know what H of 0 is. H of 0 is 21 times cosine of 0 pi over 12 times 0, which is 0, minus 3 pi over 4, plus 26. And if you type that in on the calculator, I trust that you know how to type things on the calculator, you're going to get 11.15 feet. So by typing that in on the calculator, we get 11.15. And now, E says the ride lasted 2 minutes and 5 seconds before it stopped, letting passengers on off the Ferris wheel. At this point, Charlie dropped his stopwatch over the edge of the seat of the Ferris wheel. From what height did he drop his stopwatch? So, at 2 minutes and 5 seconds. So, how many seconds? Well, this time was in seconds in this problem. So, 2 minutes and 5 seconds is how many seconds? Well, that's 60, 120, 125 seconds. So 125 seconds, and we just want to do what H of 125 is, which you can do in the calculator. And if you type that in, well, make your T become 125 and type that in and solve, you should get 36.5. And this H is in feet. That's his height. So it's 36.5 feet. So that leaves one more for you to do. I would draw a graph first. Draw the graph. then you're going to write two equations, one in terms of sine and one in terms of cosine. It's the exact same process, so rewatch this video if you need to, but that should help you get number 4 figured out.